I just have to check like my settings. Yeah, they look good. They look good. I suppose they are. Oh, but Magita can check first.
Yeah, let me just see here.
Yeah, we need to talk about something, Lemos.
What?
Well, I don't know, just for him to check the.
Oh, okay. Man.
Wait, where's the link, man?
What do you mean the link?
Twitch?
in the info chat in the lounge. There is a link to Twitch there.
Info channel. Oh, okay.
In the media part, just scroll up a little bit.
A particle.
Yeah, this is how you make.
I'll
Common-Lisp.
mute you guys. I'll get out of here and then I'll test there.
Okay.
Okay, so just for the archive purposes.
Okay.
We didn't record the last time we had an encounter.
Okay.
It's fine, Magita.
Yeah.
Did you hear my voice?
Yeah, the audio is fine.
Okay, nice.
Okay, nice. Theoretically, someone should jump and check for Magita's, but
no, I mean, like, if you guys can hear me,
no, like if Lemos is okay and I can hear you both just as good.
Yeah, that's fine.
Yeah. Okay, so the link.
Using Visual Studio.
No, I know the particle is here.
Okay.
But Visual Studio is here.
You just share the code, right?
Yeah, just to share the code. Okay, so just for the archive purposes, as I was saying, we didn't record last time, and that is unfortunate because we made all of this.
Fortunately, who knows?
Yeah, maybe. And today we would be addressing the second problem with collisions, which is checking for contents in the board. Because we just checked if we are outside of boundaries of the board itself, we are just ignoring, like discarding the content. And that should not be the case for obvious reasons. And then we need to decide how we're going to do that. Which is basically a bunch of 4s, as far as I know.
Hey, Lemos, but in the ideal world, I would like just one thing, man. Like, has collision, and then you pass a board and you pass a piece. Ta-da! That's it, right?
Yeah, we have. Oh, I didn't explain this to you, but we made this as well as like a prototype.
Oh, okay.
Advanced game stage, you have a board, you have a piece, and you're using input. If you have if you press D, we're gonna call a function that doesn't. This function exists? I don't think it exists.
Probably does.
Probably does. Why do you think that?
Actually, wait, that's the up thing? That's
wait,
the
man,
right
just use like text
no, that
search.
doesn't. No, it doesn't.
No, this doesn't exist.
Okay.
But we're not evaluating.
What is advanced game tick?
Because if you press...
No, what is? Like, is it defined already?
No, it's not defined.
Oh, okay.
This is because if you press nothing, if you don't go through this case, you're just going to advance a game tick, which is basically a piece falling down.
Actually, this function could be recursive instead, right?
Could totally be recursive.
Yeah, because we can just like do this advanced game stage recursive, like doing a tail call.
Okay. Yeah, totally. But then, Nathan, that's the thing. If you don't press anything, and we don't know how we're gonna simulate the tick, because we need to have a time window to the user to provide an input. But if he doesn't provide any of these symbols, any of these AWS basically, AWSD, we're gonna just make the piece fall down as lock. Yeah, but if you press S, you're gonna advance ticks in one single round twice, because this will be making the piece seems like the feeling would be that the piece is falling faster, which is exactly what we want when you press down. And yeah, so the only different case is when you press W, you're gonna rotate the piece. And this function is already done, and it works. Because this is only changing the piece, right? Yeah. This is why we need the board all the time, because we're not changing the board yet. We are just changing the piece itself. So we're going to be just changing the coordinates of the piece or the rotation. That was this was like a draft from previous session.
Yeah.
We're not evaluating this yet because we don't have all these functions yet. We have only the rotation.
Yeah,
Yeah, this is
Go.
I'm just very sorry that we are using like mutable data. So when checking for collisions, you probably need to mutate the thing.
Yes.
Check for
Yes.
collision and then like do a mutation to like restart the thing, right? If it were immutable data, oh, that would be much better.
No, wait.
Probably not. No, we don't need to do that, man.
Yeah.
We don't need to mutate.
What do you mean?
No, we
Unless
need
do a
to
copy.
mutate.
Yeah.
No, we need to mutate somehow, not Mageta, because
Unless we do a
Just copy and
copy.
paste
but-
the new thing, man. Like you copy, put the things you
And then
want in
mutate
place,
the copy, and then you don't
no,
need to.
you just make another tail call with the new thing.
No, Mageta, we need to mutate somewhere.
yeah, even immutable in the immutable.
The
term.
only thing regarding doing a copy is because you can do a copy, mutate the
You're
copy,
looking at-
and then if
Here's the
it's
thing,
wrong, you can
No, wait. What I'm talking about is like you do the copy and then looking at the representation of the thing, which is the shadow of the piece, right, in the board. And then we write that already. Like we're not mutating. We're just like copying the positions we want already in place.
Huh?
No, wait, Mageta, do you agree that if you have a board with like this,
Okay.
and then the shadow is like these two ones, we need to mutate the original board to have the ones inside?
And
You
by
just copy
mutate, we mean the
board with
position.
new positions of the piece.
Yeah, no, we need to go to the board, and instead of being 2 zeros, we need to put 2 ones here.
No, you copy the board with the correct position.
No, wait. I'm talking about the piece. All of the time, I'm talking about the piece. The board doesn't change until now. Only on collisions.
No, suppose this is a collision, goddammit.
Okay.
Suppose that this is the game,
Mhm.
and this is the piece. So I wait a little bit. So then it's gonna be doing like
it's
this,
gonna be a tick and it's gonna go
this,
down.
and then this is a collision at the next
Okay.
tick.
Yeah.
When the collision happens, what we need to do? We need to like materialize the shadow into the board.
Yeah.
Sure.
How are we gonna do that? Me and Nathan, as far as I can tell, we understand this as mutation.
Well, I was talking about the piece, not about that.
No.
But I agree. Of course, it's mutation.
Yeah, only mutation.
I don't see why you guys are seeing mutation there, man. You just copy the thing with the representation of the shadow where it stopped. Like, what is mutating about it?
Well, it's a matrix, right? Like an array of array. Like you
Yeah,
cannot
do you agree?
copy a matrix inside of any arbitrary position. We don't have a
Do you
structure
agree
for that.
that we're gonna go from this board to this one?
Yeah, I do.
Yeah. So how are we gonna do that?
Well, you look at the piece, and you look at the representation of the piece. If it's like colliding with something on the next stick, then you just
Okay.
copy the thing, copy the representation in the copying process of the board. Like, what is mutation about that?
Oh, okay. You mean about creating a new board, and that is like creating based on the old board and the piece. Like, is that it?
That's
passing
so
each
much harder
positions.
though.
Yeah,
No.
that doesn't make sense for me.
No, I think I do agree that's harder. I'm just saying, like, I don't know why you guys are talking about like mutation on that. Like, it's possible.
No, it's possible, but I'm voting against that. I'm
Yeah, I
against.
think that's useless. In this case, I don't think that's like necessary.
Okay. Anyway, after all this, what we need to do? We need to create a new function that checks for with each. It's gonna be something like
Man, fix the parentheses, please, man.
where?
And having a convulsion.
Oh, the one that is not on the last.
180, please fix that.
180. This.
78 now.
Oh yeah. It needs to be like one line above.
That's ugly.
What should I do the key here?
Go
Go
back to the yellow. The first one.
And just delete
Now
until it reaches
delete
the
the
other.
white spaces until you go to 177.
Like this?
Yeah.
Yes. Oh, much
Oh
better.
man, no.
Yeah.
How
that-
is this
No.
better?
Dude, this is Lisp. What are you expecting, man?
No, it's idiomatic. I will not say it's better, but it is idiomatic.
Dude, you basically you don't even look at the parentheses. Like, after you get used to it, you don't even see them.
Yeah, only when you have an error, and then you are going crazy about it.
Yeah, if you have an error, you will notice. Like, I can capture errors already, like of parentheses balancing.
No, but the thing that pisses me off is not actually the act of having a bunch of parentheses. It's just that I'm losing the scoping by the nation. Because this does, Magetta, this is saying to me that this is internal things.
Yes.
And this is also saying to me that this is internal.
Oh, but you're thinking of C. You're not thinking of a
I'm thinking of any language, even Haskell, man.
No, man. You gotta think of a 3 when you're doing stuff in Lisp. Like, yeah, because as expressions, like the Lisp thing, it's actually a 3.
No, sure, you can throw any kind of concept that you want, but to look at, it's so much easier if they are aligned.
I disagree, actually.
That can be like...
Yeah, that's subjective. Maybe if you are really, really used to it,
like
you really don't see a problem of losing scope management with this.
I don't see. I see especially there. That
hey, folks, we are getting like way out of
sidetracking. We're
sidetracked.
Yeah.
Okay, so let's make the function then. So
what are you doing? Wait, which function is this? Check for boundaries.
Def fun.
Forgot parentheses.
Oh yeah, as always. Parentheses.
It kind of looks like JavaScript without the parentheses. Now that I think about it.
Oh man.
Check for I don't know, presence in the board.
Check for presence, like in the. You want to see if there is ones in the next position you're trying to move to, right?
Yeah. Wait, you will use that inside the check for boundaries, right?
Yes.
Okay.
Mm-hmm.
Then this needs to change the name.
So remind me.
Also, this actually will be used inside the can proceed, right?
No, we're gonna do can proceed and this.
Because we already looked at the function.
Okay, because you are saying only boundaries, right?
Yeah.
Oh no, so then the check for boundaries is wrong. It needs to be check for collisions. The inner ones are right. They are checking only for boundaries, right? But this is collision in general, right?
Yes. Okay. Yeah, but like I said, forget the names. Just forget the names for now.
Yeah, look at 165. Like that was the function I was talking about. Because it's basically already checking for columns and rows if there is any one in the position you want. So in our case, we just need to check if there is like one in X and Y, right? So before you actually move.
Wait, Magetta, you said something interesting. It's because we made this to grab a piece. We call it matrix in here to grab a piece and pick a coordinate and check if we have any ones in that.
Yeah, so my point is, like, we have the point. Oh man, I wish I could draw stuff on the screen. But think about this, like, we have... Can I enter there?
The link is there.
Wait, are you going to explain the presence in column and presence in row?
Yes, but sorta, not really. Like, because they're essentially just fighting for zeros and ones. Like,
this is like this, not that.
No, I understood. That's the thing. I don't think it's needed.
Okay. No, but that's the thing. I want to hear Magetta generalizing this for the board, because this was made with the piece in mind, not the board.
Mm-hmm.
No, but see, just take a look at the name of the thing and the interface for it. It has nothing to do with pieces. Like, it's only about matrix. You got a matrix.
It's the matrix of the piece.
No. Is it?
Yeah.
Why the piece specifically?
Because the piece has the representation.
No, nothing is right. This
it's for arbitrary matrix, right?
Yeah,
but it doesn't matter. Yes, that's what I'm saying. But
it matters because then you can use for anything.
Yeah, man, that's what I'm saying, Nathan. So let me try to explain. So we have the start position, right?
Mm-hmm.
With the start position, we know that to which extent the piece will go, right? We know if it's 4x4 or 3x3.
3x3, yes.
So the only case that we need to check is, okay, let's try to move down. Like, it will always go down, right?
Okay.
So while it keeps going down, we just check on the representation moving down on the X and Y boundaries of this piece shadowing over the board. That sounds very complicated.
Yeah.
And then you basically check with these two functions if there is any ones inside this row that you're looking like below you. Was it clear?
Yeah, like one after the piece shadowy boundary, right?
Yeah, like
The
if there's
border.
anyone, like if there is anyone on the bottommost row of the piece, then that's already a collision.
Yeah, but that is a wrong thing in your reasoning, depending on the representations that we have for different pieces.
Yeah, there is like a zero. For example, that's why I wanted to draw. Let me put it in Discord.
Well, like it's just to say that your assumption is that the border on our pieces have always like at least a 1, right? Yeah,
no,
because if
the
it's
only
a
other
0...
the only other case is the bottom that we already check.
Wait, you are assuming that, okay, we have a piece and we are checking the bottom border, right? And then the next one after that, if they will collide, not. But on that, you are assuming that the last, what is the name? Row, yeah, the last row of the piece, it's not full of zeros. You are assuming that.
Which is not always true.
No, wait. Can you say it again? The last thing? I don't know if I understood.
So your checkings is, you are checking the last the last row of the piece and the next one on the matrix after that shadow, right? He's drawing. He's drawing. Yeah. So, can you do where is the whole shadow, not only the ones, Lemos? Can you do using like underscore and pipes?
Wait, the whole shadow. Here's the shadow.
No. See, but the zeros beneath these are also shadow. Because they are also piece representation, you see?
Okay, let's do X then.
Yeah.
Okay, I see what you mean.
So you see, you are assuming that those row of the piece representation.
That wasn't what I'm talking about. Yeah. So that's what I'm saying. We need to check for the collision if there is one. Like if there's not one, like that wasn't what I was thinking of shadow, by the way. What I was thinking of shadow is the representation of this thing only in the terms of ones.
That's not the shadow. The zeros are shadow as well here.
Yeah, but like for zeros, they're not gonna conflict, right? So it's
no, that's right. But
it is the data that we have, like the representation.
Yeah, we are using. I totally agree with you that intuitively speaking, it makes more sense to share a shadow only with the ones.
Yeah, but like I'm talking about like in terms of the functions. Like if you look at the always clause, it's just checking if there's zeros and ones, like if it's permissible. So it's gonna be a boolean.
No, it is, but it is checking something like, is this, for instance, if you pick this piece, this 3x3 piece that I draw here, and you pass the presence column, I don't know, and you pass this the 3x3 matrix and the number 2, it will check this, and this. Yeah, and if it find something that is not something that is it's checking all zeros.
I don't remember it conflicting with zeros.
Well, we could do some ifs to solve that, right?
No, yeah, but the always is always already doing that.
No, what I mean is, instead of checking the one after our shadow, we also check the last one of our shadow, right?
Can you repeat that, Tantan?
Yeah, it's because at least what I understood from what Mageta said, that I could be wrong, is that we have the shadow, and we are checking also the row on the matrix, the board, right? Yes. After our shadow. But
no, not after. Not after.
Yeah.
Not after?
No, sorry, you mean these three?
Yeah. That's after the shadow.
Yeah. No, yeah. Again, sorry. Let me make myself clear. In this function, all the functions that we did last time around, we are never.
Okay, I'm talking about the next function that we write, that we are going down and checking for ones to see where we can like incorporate on the board, right?
Yeah. So my idea, being honest with you guys, would be to do this pattern here. The same exact pattern, but instead of being can proceed left boundary, you're gonna be can proceed left ones.
Oh man, no.
No, I know it is bad, but that is the easiest approach, at least in my eyes, because we already have this pattern.
Isn't better for you to do inside those functions already?
No, okay, man, but explain to me what you want to do in procedures. Like, don't talk about functions, just talk about the piece. Like, how would that work?
Okay, so how would that work? I would, if I'm doing, let's pick an example here. So can proceed down, bottom. This is the easiest one. Can proceed bottom ones. What we would do here, I'm gonna pick the piece. I would do presence in row and grab these three. See if I found a 1 here.
That's the same garbage that I was talking about.
And then if we have a 1 here and we have a 1 after the shadow,
yes.
In this particular case of can proceed bottoms is always the next row, right? If we have ones here and some of them collide with these ones here, collision.
Yeah, that's what I was saying. Like, you just slice the bottom. Like, you don't need to check for everything. You just slice.
Yeah. Oh, I see what you mean now. Slicing these. Only this matters.
Yes, exactly. No, actually, not all of that even. Like, you just slice the part that is like casting down the thing. Like all the ones over the X. So like fill the other ones with zeros, just to show.
Which ones?
176. Go to 176
here.
Yeah. Wipe all these ones preceding this.
0 here.
Yeah. So no. I mean like the ones preceding. So like the 3 first ones. This should be like 0, let's say, on the slice, and the last one as well.
Wait, repeat the last 2 sentences.
Go to the last one.
Here.
Go down.
Here.
Replace this one with 0.
Here.
So that's the slice that I'm talking about, which is the shadow that the shadow is casting over the row. You see? Because you just need to check if those guys are actually colliding or not.
Yeah, that's the thing. I agree with you that with this procedure, which I think Nathan has a more generic way of doing, so this is why he was complaining, because I agree that having this separation between directions is kind of bad.
Yeah, but we're going to have to redo that, and I don't want to redo that.
No. It's the opposite, actually. If Nathan has a better idea to do with the check for once, later on the line, like in a future session or offline, we can just redo this as well. We cannot, like, I'm also pursuing the best abstraction, like the best way of doing things. I agree that this.
I think we're lucky if we finish this.
No, Magueta,
when I saw this at first time, I knew this, that probably there is a generic way of checking this, and we are just yes. So that's the thing. So now I hope that for Nathan is clear, because Magueta and I, we were saying the same thing. I hope, Nathan, that now you understood what we were talking about. And now you can try. Not really.
Can you go again?
Yes, I can repeat. So my idea was pick this, right? You have actually not pick this.
Wait, can you mark all of this a comment, because those colors are freaking me out, man.
Just one semicolon works.
Oh, I hate this. Okay.
Oh.
You don't know that. Anyway, what we are talking is, we're gonna pick the piece. We need the position only to know the contents of the board.
Yeah,
right. So for now, ignore the position. What you're gonna do? You're gonna use this function here. Actually, ignore this function also. I'm gonna abstract this also. So ignore. You're gonna pick this row. Okay. Because this is part of the piece in this specific position. Actually, this is the part of the shadow of the piece. Sorry.
Man, it's just for you to call.
Don't say shadow, man. Say box. It's better.
Docs.
Box.
How is that better?
Box. Well, the piece is inside the box falling down.
Oh, this box, not docs. Okay, box.
Okay.
Anyway, these 3x3 whatever. This 3x3 whatever. If you want to go do can proceed bottom ones, which is we already know you are trying to push down the piece. You're gonna just pick this row and the row afterwards.
Okay, so the border and the next one.
This is not a border, by the way. This is.
No. The border of the piece, I mean. It's the last row of the piece.
Okay. The border of the piece. And you're gonna compare 3x3 or 4x4 members below it. And if you have this matching this, or this matching this,
Wait,
or
what do you mean by
matching
this matching this?
This is one and this is also one.
Oh, okay, collide.
Yeah, if they are both ones, this means that we have a collision, and this means that we need to do something about putting this onto the board, because right now this is just
okay, but you will need extra checks also. Do you know why? Because if there are zeros, then you will say can't proceed. But in the next round, see what is your state. You will have to check something really different.
Oh, it's gonna collide. No, it's the same thing. You will collide, and it will say, okay,
no.
so
repeat the same check
further.
again. Like,
can you tell me what's the difference between?
Like,
move
put the piece down
once.
Yeah.
Okay, so
don't modify in place. Don't modify in place. Just like copy down so we can.
Okay, that makes sense. Okay, so what you're saying is that
do a step, right? Do a step down.
Do a step. This will be 1, 1, 1, 0, 0, and here will be 0.
No, yeah, use the axis.
XX. Use X. Yeah.
No, where is X?
No, you see.
Only two ones. XX.
No, this is not XX, because after this collision.
Oh yeah, no, wait.
Oh, it
I
makes
was
sense.
thinking of another step. Yes.
It makes sense. It makes sense.
So this is a step, and there are 3 axes which are zeros. This is just like to represent that it's a zero part of the piece.
Where those ones are, you see?
Yeah, we're gonna have an XX.
So you see the next check that you will make. The one after the border will be out of bounds, so you need more checks, right?
He's talking about these ones, Mageta. They are on top of these zeros, right?
Oh, okay, I see. Because we moved down the piece, so we
and the next one will be out of bounds. Then you need the extra if for that.
Exactly. We will need to
or default case. If it's still, it's 1, right?
We can do a. Well, this is not appropriate, I guess.
I think the default case it's the simpler because
I think of like moving the entire piece down, and like if it's 3x3, we just move the piece down like to the bottom thing, and it's always gonna collide on that check.
I think we will like shoot ourselves if we consider to specify specific pieces, like if we highlight too much on representation of pieces or in different pieces, I think that can be really bad.
And Magette, there's a problem with your idea, because that's not always true, man. Because for instance, if you have a piece like this, if you have this piece
that has two zeros, right?
Yeah, 2 zeros. If you have like two rows of zeros, like this, the next one will also not collide.
Yeah,
see?
This is easier to guarantee taking a look on our representation, but it still would not be generic.
You're thinking of a straight, right? Because the straight will always have one bottom.
Oh, we have that case. Oh.
Yeah, it's this, by the way.
Questions?
Oh, hello, Commander.
Yeah,
hello.
I have like 10 minutes maybe before I go to sleep, but I decided to check you out.
Okay, so what we are doing now, we are not only updating Latam with the improvements, quote unquote improvements that we did last time around, but we are also trying to define a strategy to do collisions with the borders content of the board and the shadow of the piece. Because like we told you, we are handling the piece and the board in a separate manner. And we are just we are controlling them separate, but because they need to be seem to be together, we are thinking how we're going to do this, and then we have a terminology called shadow, which is basically the piece representation. The piece is floating, and then the shadow of the piece is being on top of the board. And then we are trying to define what is the best strategy to do collisions with the ones already in the board. And we have a problem because the ideas that me and Nathan, we were proposing, they were not generic, and that would cause a bunch of ifs in the function. And Nathan appears to have an idea to make it the generic with regardless of the piece itself. And then we are kind of trying to understand his point of view while explaining ours. And I think that summarizes it. So unfortunately, we're not coding right now. So thanks for the help, Commander.
Sure, I mean, you can still, like, if you will, at the end of the session, you will have some questions, you can post them in the chat.
Okay.
And I will maybe answer them tomorrow.
Okay, thank you. I appreciate that, man. Thanks.
Okay, well, since that's the case, I'm gonna go to sleep, I guess.
Good evening, man.
But thanks anyway,
Good
like,
night, man.
we received like a
Yeah.
buff from the list
Yeah.
chat.
Yeah.
Good night, man.
Good night.
Alright.
Okay, so Nathan, now that I think everything is clear, both for me and Nathan, and I knew this would happen, Nathan. I knew.
That case sucks, man, because it's there are only two pieces that are special cases, right?
Yes.
Actually, no, just one piece that is 4x4, which is the straight, and that piece
No,
is like
the square is also a 2x4x4.
Oh yeah, the square is also, but the square is not a problem because you can also move
Yeah,
down.
it doesn't have 2 rows of zeros, right?
Yeah.
Yeah.
Anyway, the thing is, Nathan, now that we explained our idea, now you can try to do yours.
Oh man, never mind. Even if we rotate, like not the special cases on my case, if we rotate, it's gonna end up with zeros like in other positions.
Like, there are ways to solve it. Like, we could just change the way that we are doing that piece in particular, right? But I don't think it's a good solution.
Yeah, it's terrible.
Yeah, no, it's not generic, and it's a bunch of like we need to handle so many corner cases. Okay, Nathan. Now, enlighten us. Put light on our heads. In our heads.
Oh wait, you already know how to do it.
I don't.
Do we?
I don't.
I'm sure I got your thing.
Okay, go there when we are matching user input.
You're talking about entering the thing in here?
No, go there. On the...
No, but Magetta said something. You said what, Magetta?
No, I said like I don't know if I understood Nathan's point.
Oh, I don't. I also don't.
Oh, okay, because you entered after. So go where we are doing the match on the user input.
Here.
So my proposal is, if the user input, it's like go to the right, then what you do is mutate the position of the piece, and then pass the piece and the board, not in that order, to the is having collision or something, right? And then we check it, and then I will go after in how to do this. And if it collided, then we have to go back, right? So mutate again to undo what we did. See?
So you're thinking of like, okay, I think I get it.
Right? And if
But
didn't
what
collide
are we gonna... Okay, but how do you check the collision? You check if it's like conflicting with
before
one,
I'm
right?
talking about like this function, right? The higher level. Then we can go in how to
No,
collide.
okay, like this part is fine. Like
Okay.
I get it.
So let's go into the collision. And how do you do it? Like, you basically have the initial position of the piece on the board, and you have the representation. And how do you do it? You have the coordinates, like the indices of the matrix of the piece, and you will iterate over that and over the shadow. And how to iterate over the shadow is just to use the initial position and the indices as padding. You see?
Okay, so you're gonna do three iterations.
Okay,
You're gonna iterate
I get it.
across the piece
No.
and iterate across the shadow or in the board of the piece.
The iteration on the sense of going through a
Oh, man, I
data
understand it.
is only one iteration. But on that iteration, we will use the indices and also the initial position to get a element from the
It's a lot
piece
simpler,
and
man.
one from the shadow.
It's indeed a lot simpler. I'm just like confused with one thing. Like let's suppose you try to go to the right and you reach the barrier.
The out of
like,
bounds,
you have
right?
Yeah,
The
but
out
you
of
have,
bounds,
like-
we treat the following.
Yeah, but wait. Not that yet. Like you're going there, and your piece has a column that has zeros, like on the right.
Yeah.
Oh,
So
so let
how
me
do you
draw that.
How do you check the collision in that case? Yes, think of like an L, something like this. Like a straight
Well,
is fine.
it's not a special case because we are checking if it's having collision of both elements are one. If it's not, it doesn't occur anywhere.
But that's my question. What are you checking off the piece?
Okay, I'm iterating over the indices of the piece, right?
Yes.
So I'm checking that element versus that element on the shadow.
Oh, like for every other element, right?
For example, any element. For every better.
Yeah.
Okay, so I'm still a little bit confused. I think Magetta understood better than me. I want to ask, so you're gonna be iterating through these guys, or is that wrong?
Can I try not to?
Huh?
Can I try to explain to see if I got it?
It's better.
Think about these labels. Like the way we are doing, we are checking like the corner cases, right? So okay, what happens when you try to go right? What happens when you try to go left? What I'm suggesting is you have this function that is very generic. So what it does is it goes on the first position of the piece, and then it goes iterating over each position.
So these ones, X,
yes,
X, okay.
Looking at the corresponding position of this shadow in the board. So think about like a piece floating in the air, and they are looking at each position in the board, like corresponding to the board.
Okay.
And then for each position, you're basically checking, is this one? And is this one as well? No. Okay, so keep going to the next.
Okay. So let me try to do a little bit of visual. So like this would be.
Can you make
this would be the board. This would be the board without the shadow. Would be this 3x3 here. You're gonna iterate through these 1, 0, 0.
Wait, I don't know what, dude. Oh man, I wish I could enter that. Let me share my screen. I think it's easier.
No, but this is the previous. This is the previous board. Like this is the board itself. Actually, this is the board, and this is the board with the piece floating. The piece floating.
Can you see here?
Let me see. Magetta, do you have like a clean environment, like nothing that could show on string or something?
Yes. It's just Emacs, man. Sure.
Okay.
Yeah.
I don't know. Maybe you have like secret configurations on Emacs, right?
Like I don't know, animes like this.
Credit card on Emacs configuration.
Yeah, my Emacs configuration is public anyway. So think about this. Like, let's make the following. I'll just make ones here. Like, let's suppose that we have like this structure that is already in the board, okay?
Okay.
Actually, let's think of this. Easier to think.
Okay.
So we have this structure already in the board. Oops.
What the fuck is that structure?
Yeah, like just ignore.
Yeah, this is a totally possible structure. By the way.
This is a possible.
Yeah.
And I'll make here the piece, right? So I'll make the piece like. So let me actually make like this so you can actually see what is the shadow of the piece. So this will be ugly, but imagine that these two ones here are also like shadows, okay?
Okay.
So, and imagine the piece we are looking for is this one, is the block piece. So it's like this, right?
Okay.
So we are just gonna check this position. And then, okay, so what is the shadow that this position is causing here? Actually, let's make the full piece because it's 4x4, right?
Yeah.
It's gonna be 1, 2, 3, 4.
It's the whole thing.
Yeah.
Holy fuck.
Anyway, so this is its shadow, right? So every other thing will be X.
Oh no!
Oh
no! But that's a lot really better for comparison.
Yeah, okay, that's a good one. That's a failed good attempt. Or a good failed attempt. But anyway, so everything is casting the shadow here, right? But the only thing that is actually conflicting is here. But what I'm suggesting is grabbing the initial position, which is this one that I'm highlighting on my cursor. See? And then you go here. Okay, is this conflicting? No. Is this? No. Blah, blah, blah. And then you check everything. And then when it goes here, then it's going to see, oh, it is conflicting. So just like yield true. So then we're going to know that this position that we're trying to move is actually conflicting. So, and it works for any other position, so it doesn't really matter. Like if there is like something here, it will conflict.
Okay, so we have two kind of ways of do that. We can do like a bunch of force to and then. But I think what Nathan was saying that we just need one iteration through the piece.
Yes.
Because we can just add the dimensions of the pause,
projection,
right?
The piece and the projection the piece causes in the board.
No, it's only one iteration, but in that iteration you access piece representation and shadow.
But you need to adjust one of them. And you adjust using the position that is stored inside the piece, right?
Yeah, in that one, it's a coincidence that both have the same representation, right? But in real scenarios, you would use the initial position.
So let me do a better example.
Okay, no, but now I think I got it. I totally see it.
There are only two notes for it, Lemos. The first one is regarding out of bounds, right? Because when you go out of bounds, what I was thinking is, considering the element that you access, if it's out of bounds, then it's 1. See?
No, let's go with the out of bounds later. Right? Let's implement just what we all of us understood.
No, it's because it's the same function on the same line. It's literally like that already, you see? Even though the concepts you may think as a different thing, the implementation, it's the same thing.
Okay, no, but later on the line we can do that. Let's just implement the first collisions with the ones. To get to be a little bit productive.
Move down, man. Look at this. This is fancy.
And oh no.
Let's do it then.
The function itself, it's literally like we are writing a function that receives a board, a piece, and we check for collision. Like you don't need anything else.
But then I have a question, Nathan. I think that in order to your thing to work, we need to move first and then check. Is that right?
No. Two things. First of all, that's outside the scope of this function. You see, who is calling?
I think it's necessary.
No, it's not. It's not. These will have only one concern. These two that you send me, are they colliding? That's it. The management of movement we do outside.
Yeah, we do outside.
And I already told you how to do it. And
okay, so the first thing that I think we need to do is to add to destruct the board, to destruct the piece in this time around. Am I right or not?
Yes, the piece.
Yeah, to get the piece rows and get the piece columns. We just do array dimensions of the piece.
Yeah, they are not really piece rows or piece columns, right? They are the size of that. Am I right?
How many rows the piece has?
Yeah, but see, piece rows and how many piece rows they are different.
I don't know if I got what you said.
When you name it piece rows, it seems that you have the rows of the piece and not how many rows do you have.
Okay, I don't have a better idea for naming them.
Yeah, I also don't.
Like a Java name, I don't know.
I don't know, like piece row size. I don't know.
Okay, so but anyway, regardless of the name, now we need to do loops, right? Am I right? Oh, and you also need to do destruction bind with the. Can we do multiple destruction binds?
Yeah.
No, but it's not what we want to do. We want to do this.
By the way, folks, is this right? Like, if I have a 3x3, what will be the value in piece rows and piece columns?
3 and 3.
So we need to do a -1, right?
Okay.
No, because we can control that with the loop, if it's inclusive or not.
Yeah, below and like that below checks like
below and after.
Oh, okay, nice.
And I'm already messed around with the parentheses. Nathan, please save me.
Nathan? You are confusing your names, man.
No. Look at this. Like, look at the colors. Look at the colors. What is wrong?
What is wrong? I do remember Commander saying that the let is including.
Yes, but think about this. Ident first. Right. So the structure, the let is inside the structure bind, right? Yes. So what is wrong there? Like, put the parentheses on the proper place.
Proper place. Nobody understands.
Yes. Okay. Now you can look, like, you can literally compare and see. Okay, so this is in the same level. you're going there to the blue, and then this is the blue for the let, and then you have the purple for the. Oh man, why do you do this? And then you have the purple. Like this in this case, it's not good, but like try messing up the parentheses on the check for collisions, the bottom function. Like I don't know, remove any random parentheses there.
No, we don't have to because it's already okay. So this blue is for the can proceed. This purple is for the one of the cases. This is for the case itself.
Yeah.
This is for the let. This is for the instruction bind. This is for the function itself.
Yeah. Now, okay.
Now?
Why do I think this is good? Because if you're not indenting properly, then you will lose this structure and you will get confused on which like parentheses go where.
I am already confused by this, by the way. But anyway, I want just to know where should I break the parentheses here?
Okay, so go to you see the blue? Not
Yes.
This, yes, the second blue. Go
Yes.
inside it because it's
Yes.
part of the let. Enter.
Yes, enter.
Indent properly. Now you do the thing.
Okay. Okay, so what we want to do here, and this is not initial position, by the way. This is, I don't know, out of names, man. Pos 2.
Yeah, this
don't
is
care.
the initial position of the piece, right?
Yeah,
Wait,
okay.
what the
initial
fuck?
position.
Posture.
Posture.
Initial position of the
Why
of
not
the
doing
thing
this on Emacs, man?
Piece
we
position on board, right?
let's do it in Emacs then. Because
Yeah,
I do have
because there it indents properly. Like you
No,
don't
it's
need to-
terrible because it don't have colors. It's even worse.
Just do like this.
Then
no,
it
no, no,
will be
do
nightmare.
like this. No. Do the following: meta X, package install,
Is this gonna work? Package install in here?
probably.
Ooh,
Oh,
the
we
guy
also
is
support
bold.
Do the rainbow delimiters. See if it's there.
Installing packages live.
parents.
No, not only that, we are
No. Complete.
No,
Yeah,
I
see if
see.
you
You are
will-
not writing your configuration, right?
No, this is a random program called Protocol to have Common-Lisp in Windows, man. Anyway,
Oh,
it's
okay.
rainbow
Yeah, like,
delimiters
it's a
here.
really common bundle, right? They're just making it easier.
Yeah, it's like this, not Magetta.
Yes. No, it's with a dash in the middle.
Like this?
If it doesn't work, you can just plus this. Yes, I think so.
No match.
Okay, so do the following. It's not there. Just copy that part. Eval.
Copy what? Sorry.
I sent on
message.
Discord.
Oh, in the chat.
Yes. On the group thing. Actually, I'm gonna remove the
Just a
comments.
little snippet of code.
There. So just those 3 lines, man.
Oh man, no.
You're laughing, man.
It's hilarious. The chaos.
Just
the chaos.
eval.
The Control X, Control E
Control E. Go to the end.
No,
Control
Control-
X, Control E.
here. Abort.
Condition. What? Oh, this is not. It's understanding as a Lisp mode. So do the following: copy the shit.
Hey, folks, wait. I don't think that's worth it, man. Just
No,
use
yeah,
it
it is,
in
man.
Mac.
It is. It is. Dude, it's just 2 seconds. Just do it. Q. Press Q. Q. Yes.
Q, okay.
Cut these 3 lines.
Cut
Control
the,
A.
cut the lines.
Cut the lines. Go to like another buffer. Do another buffer like Control XB. I don't know, buffer. Like make a new name, whatever.
Scratch. No, not Scratch. We are in Scratch.
Scratch 2. I don't know, man.
Whatever.
Yes.
Okay.
Okay. Paste.
Okay.
Now eval there.
Okay. Control X, Control E.
Okay.
Control X, Control E. And Control X, Control E.
Now package install again.
Package install and rainbow
We should complete. Rainbow.
delimiters.
Yes, enter. Why are you laughing, man?
Because this is so random out of nowhere, man.
Oh,
Certificate always. Or just session. Press S. Yeah. Not found. What the heck, Melpa? I think it didn't download.
Okay, so it didn't work. Anyway,
Yeah,
let's
anyway.
continue here.
Yeah, but if you just hover in the parentheses, fix themselves. Think that you are in the 80s with a Lisp machine. They don't have colors.
that doesn't sound like a good
No, it doesn't sound
environment
Think
slash
think
scenario.
of the sounds. Your Lisp machine is doing kadr, kadr. Anyway.
Where is the thing? Oh, it's here. Okay, so collisions on the board. Okay, so what we need to do here now? We need to do a loop, right?
Yes.
Yeah.
Parentheses again, I guess.
We could do a loop or let me see, or a map. Actually, not map, like an ether, right?
I think that the loop is the one that we have more experience
Yeah,
with.
let's go with a loop. Okay,
We should
loop.
go with a loop for
Or
whatever.
The
you
nice.
can loop over the position. I don't know if the loop works with the matrix though.
No,
Probably
but the
not.
loop is like 0 until the end,
Yeah.
right? So
If you just do for E, it goes already from 0 until that guy. No,
Yeah,
no, no. For E.
E. Like
Yes.
this? E.
Yes. No. E, like I.
Oh.
Sorry, English. English.
English.
English.
Okay, so what you want to do is two loops, right? One that goes through the
Yes.
rows and another one that goes through tab. I don't have tab. No, I don't have tab.
No, you don't need to worry. The parenthesis is wrong. That's why I did there.
The parenthesis is wrong.
Go inside the rows. No.
Inside the rows.
Inside, yes. Enter.
Oh.
There.
Loop and then
No,
for.
wait.
Don't you need to do some
do,
action or?
Yes, that's what I was saying. Like you need to do a do
Oh.
keyword.
Okay.
No, keyword.
Oh, sorry. Do.
Do, and then you do a loop inside the do.
Do you need
Oh,
parentheses?
Yeah, you need another parenthesis now. Because this is another loop. Yes.
Okay. For J below. This is the way, by the way, Nathan, that we are doing the inclusive and non-inclusive, whatever.
Yeah, I remember that, I guess, for the
Columns, piece columns, and then.
And also we
this
have
is
the
inside
default
here.
0, right?
Mm-hmm.
Then we have another do here,
Yes.
I guess, like this. And now we need to do something.
Yeah,
Right.
let's do let's, I guess.
Yeah, let. I think let requires a new parenthesis. Is that correct?
Yes. Everything requires a new parenthesis. Oh
Look
no,
at this.
the parenthesis is wrong. Go back.
Oh my
There.
god, that's such a headache, man.
There. I don't know why you guys complaining, man.
No,
Just go.
especially when they don't have colors, man.
Yeah, especially.
Let. Just
Let?
don't see them. I think I will make a package to turn them transparent. Like
Man, but if
stop
they are
complaining.
wrong and we are not seeing it, that's even a bigger problem.
yeah, if you don't see them, you can't mess them. You just do like a strict mode.
No, that's not true.
Okay, so let what? Parenthesis now again, I guess.
True twice.
Twice.
Yes, because let me explain why you need twice. Because think of look at 172. Do you see?
Yes.
So why do you need twice? Because it's a list of bindings. So you need to assign the parameters like to the x and y. Let's say y is the thing that you want to assign to x, and then you can put many in there. So this is a list.
Okay, makes sense.
Okay, so piece value, and
That's
then
how you know it's a macro, by the way. I think.
and then you do another parenthesis here, I guess.
Yeah, you don't need two. Why do you want to do
No,
that?
you will probably need because you probably execute something in
Yeah,
there.
if you execute, you need something. Yeah, that's true.
And we need another thing in this let, by the way. We need to get the piece representation, the matrix.
Go inside. Yes.
Inside
Enter.
this.
Enter.
Or this?
No. Yes, there.
Okay.
Enter.
Parenthesis again.
Mm-hmm.
It's gonna be like matrix, piece matrix. Let's call it that. Piece matrix.
Why
And this
not piece
parenthesis-
representation?
Because it's too long representation.
Oh yeah, piece matrix, okay.
Okay. Then now we do a ref, right? I think this makes sense. A ref piece matrix. Okay. And then we need I and J.
Yes.
That sounds reasonable.
That seems correct.
It's enter here? No, enter here.
Holy
What do you
fucking
think?
I think
shit.
it's in here. I think it's in
No,
here.
that's wrong.
That's
Do
wrong?
you want to declare a new thing? Like what do
Yes.
you want to do? Okay, so then it's there.
It's here.
Yeah. If
Really?
You if you want to declare a
Nice.
new thing, it's there.
Nice.
Board value. It's gonna be a ref
Mhm.
board. And then it's gonna be
Yeah, now
A
you have to do arithmetics.
yeah.
It's initial position plus the I and J.
Initial position. Oh, but there's a problem because we need to deconstruct this in here. Oh,
Wait,
no.
deconstruct what?
The position, because it's a tuple, right?
Yeah, we need to deconstruct
Wait,
this.
can you... Oh, wait, how is the position? Can you make an example?
A
The position
tuple,
like this.
like X and Y.
Oh, like this?
Yeah.
Just do car and coulter.
No! No,
Why?
no.
No, use the element, man.
Can we do another destructuring bind and aside from this one?
Oh, that would
Dude,
be...
why don't you just do like let star and...
Oh, that's also a possibility. We can do a let's start.
No, I think that won't help.
No, the structure binding would be really good, man.
How do we do a
It doesn't matter, man. It will be the same thing.
No.
Just do a let's start.
Yeah.
I'll show you.
It's not the same thing because it's two
Yes, it is.
two lines instead of one.
Now do a new line on the thing. No, on the after. I think it doesn't matter. It's recursive anyway. So just make a new thing, like a new whatever. Yes, and the indentation is wrong, by the way. But make your stuff like for the variable, like you want to make. What's the name of that? Like, I don't know, for the first position.
I don't know.
First position, like I don't know.
First X.
And why
First
did you
row.
start parentheses?
Then I add a new parenthesis here.
No, why did you start the first parentheses? Like first row, why is it inside parentheses?
Oh, it's like this. Sorry.
No, it's not.
Man, it's just the identifier.
Remove the outer parentheses. Yes, there. Indent. Press tab. Go to line below. Press tab. Yes, so that's correct.
So this is gonna be first row,
Mm-hmm.
and this is gonna be
Wait.
cut.
First row.
Cut. No.
Cut.
What the
I
fuck is
don't
that?
remember anymore.
You can do
It's like,
alt.
car,
You can do the
car
following.
position.
Think of C now, okay? So do alt the initial position 0. It's basically assessing. Yeah, or car. That
Car is
works.
fine. Position. Okay, it's fine.
Okay.
And then we do the same thing for
Go
the
to the-
first
yes.
row, first column.
Yes, which is coulter.
First column. Whoops.
Yeah, but this name is terrible, man. It makes no sense.
It does if you are in the 80s.
Wait, I'm not talking about
No,
car
he's not
and
talking about
coulter.
he's not talking about that.
Initial
I'm talking
position.
about
The first
first row and column, man.
Oh, okay. Thought you were talking
First
about coulter.
piece, bro.
again.
Like, that's the position, right? Why not, like, piece pos X, piece pos... I don't know. Something that indicates which one is
Piece
the X
better.
and Y, right?
Pause.
Oh man, why you increase the name of the thing? Just make like X piece, man, whatever.
Yeah.
I think this is fine then. I think this
Okay,
is
now, by the way, the coulter will return a list with one element, with the tail. So do car before the coulter. Or just
but I
do
need to-
coulter. There's a function called coulter. Yes.
Man, I think that
No,
X and Y
no,
is
no.
so much easier
No,
than
it's
row
the
and column.
contrary. It's the contrary. Kader. You did kadar. Yes, kader. Yes.
Man, change that to X and Y. Like, it's much easier for me, at least.
Yes, thank you.
okay. So this, going back to the point, this will be I plus piece pos X, right?
Yeah.
Then J plus piece. Oh Jesus.
Oh, man.
You didn't notice, right?
Pos Y, right?
Mhm.
I guess so.
Polish notation.
The plus is on the wrong place.
Oh, again, I always forget this. This is always it is prefixed.
I
Okay.
say Polish notation, but I think that's not how people say in English.
Okay, so now the question is, I don't remember. This is the value or a reference to a value? I think this is the value this is all the value already, right? Like this in here.
Yes, I think so.
Okay, now we need to do an if, right?
Wait. Like, the
Wait,
default case, it's literally just changing that line. So, where we are getting... Oh, no. Yeah,
I don't know
like,
what you're talking
this board value, you see? What
three
happens if we
parentheses.
access something that is out of bounds, Maqueta?
No,
inside the
forget
list.
out of bounds now. Forget that for now. I'm already frying here. Don't. Let's just do this first,
Oh my god.
and then we add the case of out of bounds,
Okay.
boundaries. Okay.
I think I'm not sure if it will go out of bounds though.
No, it can
because it can because of the X, right? It can be out. Yeah, okay, so go to the yes, enter. Yeah, you're getting right the parentheses.
Man, how many parentheses do you already have?
Oh man, you were
a lot of them.
Okay.
See,
the indentation is amazing, man. It does the job for you.
I will not criticize anymore. I think I already did enough. Okay, now we need an if. Does everybody agree with that?
First of all, why do you what are the conditions for the if?
Like you just check equal. Because if equal 1 and both values.
Just an if without an else?
Huh?
Just an if without an else? Like what are the conditions for the if? I just want.
No, it's a when. We don't have an else.
Yeah, okay, that's why I'm saying, because there are 3 representations that work best, and each one is for like one case.
No, folks. If the result of the function is true and false, we don't really need the if, right?
No, but I want an if here, because if the first time we match a 1 and a 1, we just return whatever.
Okay, I forgot about the short
Just return whatever. Okay, how do I do it? Parentheses?
Yes.
Then let me guess.
Which is the condition?
Board value 1.
Okay.
And how do I do an end here? Another parenthesis, I guess.
Yes, and then you call end.
Okay, and.
Yes.
Oh, we actually need the flag, Lemos. Since we don't have the fold accumulator, we need the flag.
And you forgot one parenthesis in the end.
Wait. Can't we use like equals with more than 2 values?
Don't know. Board value.
Yeah, you can. Actually,
piece value.
Good question. I never tried. I know you can like sum a list of stuff. Like
okay, why is this not right, Maggie?
Go to the end. Let me check. I think it's like in 1. Oh no, it's actually right. Okay.
No. Okay, so what we are doing
here?
How
can you see that?
No, it's because it's pink. It's pink.
Yeah, it's blinking. See?
Okay.
It's pink.
Okay, so what we are doing here, we are checking if the value of the board value is 1, and we are also checking if the board value is equal to the piece value, because that would mean that both are 1.
Okay, yeah.
We can just do also, to be more geometric, maybe just put piece value 1 here as well. Yeah. So we're checking if both of them are 1. If both of them are 1, we do something, which is here.
We just return true, right?
But we need to break the loop. Is that possible?
Good question. I don't know.
Do we have return in Lisp? Is that expression based, right? So
break Lisp loop.
Return. I don't think the last thing you declare on the thing will do the return.
Oh no.
But I'm not sure about the
not if
loop.
that would escape the loop, right?
Okay.
Oh, there is a return.
Yeah, but wait, that's not for. You wrote.
Look at this rating, man.
-1.
Oh no.
Yeah, try a return. See the documentation. Probably will show.
We need to return a value, though. That's the thing.
Oh, okay. So.
We need to return a value out of nowhere. In this Lisp equivalent or break loop, similar to
return.
Yeah,
but,
I think.
No, but go back there. Go back to the code.
Go back to the code.
Just one thing. Can the loop return a value? Because if it can.
Yeah, it can.
Oh.
We can put a value here. Right? We can just
assign. Yeah, that also works. He just wants to assign a new thing. Like
I don't know.
setf.
Yeah, setf.
No, I thought about the flag, but the thing is, regarding short circuit, we don't have one this way.
You don't need to do that, I guess.
Well, you don't need, but
new.
Would be nice.
Oh,
new is false. Yeah.
New is false.
Which is an empty list. So actually, an empty list is false.
Okay, so now we need to do something like a setf, which I already forgot.
But wait a second. Let me think. Do the type return.
Then you don't need whens. You just set to the result of the comparison, and the last thing you do in the
No, we need when, because if you do a when and a break, this is more performatic. Because if you encounter
what is your break like?
No, I will add a return here.
Type return, please. Enter. No, it's go after the return and type space. Okay, so you can put a value. See, optional value.
Oh, you can put a value here.
Yes.
Holy.
That's what I wanted to say, and they were like doing all this stuff. Okay.
And we hope that this returns the whole function, right?
Yeah, we are hoping that this will return in the entire
So
function.
we need to do the other thing, but let's assume that the loop ends and it never finds the thing. So it needs to return
hey,
new.
I think we are being too. I think Nathan has a point, because even if we don't short circuit this, which would be more performatic, this loop the max size of this loop is going to be like a 16 iterations. You see?
Yeah.
So we are kind of getting like, oh, we're trying to squeeze every single bit of performance, and I'm not using that hat at the moment. I'm using the hat of I want to get things done.
I think it doesn't matter, man. Like,
no, it matters, because Nathan is right. We could just do a set here.
you can do the always. You see the always there?
Yeah, they're always here.
So we can just do a loop, and then we say, okay, always.
What is
get
the always?
condition.
And what
always is like
it's return true if this is always the case.
Yeah, for all. It's like a list for all, blah, blah, blah.
But this will be a never. This will be a never, not an always.
Yes.
No, it depends. Like, you can do negation inside, but
yeah, you can just negate them.
Okay, so let's try it then. Let's do never.
Yeah, but
and then the condition is this, basically, right? And whatever.
Yeah, but can you do that inside a do?
I think you can, man. I hope.
I don't know, because that thing like is not inside the loop. It is inside the
Can
do.
we put let's inside the never?
yeah, we can.
You can if you return the last expression as a probably you can. Just remove that here. And put never. Yes.
And then we do these let's here, and then we finish with the condition, which is gonna be.
Yes.
Oh fuck me! I need to remove the parentheses now. Okay.
No, delete the 180 first.
180. Okay.
Yes.
Magita, can you explain the never again?
So the never is basically the opposite of always. It will say if this thing should never be the case. If it is, then you just throw the thing.
Yeah, it's short circuit.
No,
so
it didn't
it's false or true.
Me. Okay.
False or true.
I'm passing a condition, right? If the condition never realizes, what is the result? True or false?
True.
Okay, it's affirming that something never happens. And in the case, that will be the collision.
Yes. Okay. So, is this correct?
Yeah, just change that name.
Just discover. Press Alt A.
Alt Meta E. Okay.
So it is correct.
So,
which name?
Has collisions. Or has collision, right?
Had collision, because I think this would be in the past.
No, it's has collision. You are passing to things we don't know regarding.
Okay.
Do you guys think you can survive if I go?
If you go?
Yeah, I'll be back. Like I'll just have dinner. 15 minutes, I guess.
Can you guys survive?
I guess so.
I guess we can.
Not as easily, but yeah.
Okay, I'll be back. By the way, are you checking if there's any messages? I didn't.
No, I'm not checking if we have.
I'm not.
Anyway, I'll be back.
Yeah, but I doubt it. Let's just check.
You are showing your screen, by the way.
Yeah, I know. Yeah, nobody. So it's fine.
Oh, actually, I'm not sure if... Oh, no, actually, that is somebody's, because you just entered the chat. But I think that Renan is or were here. I don't have the time.
Okay, so I'm bad. I'm sorry, Renan. Anyway. Okay, so Nathan, meanwhile, we could do the improvement with the boundaries now.
Yeah, but then we need to know how to use defaults, and we need to know what happens. Oh, we can do all of this, right? So first of all, check the aref accessing a invalid value. You can do that like outside this function, right? We just need to evaluate something to check if it's new.
Okay.
What I want is you will access with href
I already forgot. How you do a list is like this?
I don't know.
Oh, nice. And then we're gonna do for here. Control X, Control V, I think.
Oh wait, do you have too much parentheses there?
You think so?
Yeah, on the list.
I don't think so, but let's go.
Man, the thing is not a function, the single quote.
Oh, it's. Oh wait.
Just delete this.
No, it's not. It's not how it works, man.
No, now it's fine, but you had like too much. Right?
It's not of type array. Okay, so we need an array, not this. So
Don't
let
you
me
have like
remember.
make matrix or something? Oh, okay, make array.
Make array. Make array. This is a list. We want to do. This needs parentheses though. It's gonna be
then make array.
Array. It returns wrong number of subscripts. 1 for array of rank 3.
Wait, where are you seeing that?
Here on the right.
Oh, okay.
Okay, so what makes array expect though? I have no clue.
Man, we just saw like there, right? Take a look.
No, but this is a 2 by 2 array. Oh, it's because I need to say the dimensions. Okay. Before actually passing the thing. Actually, you can just search it. I think we are smart enough to search that. So list to array, Common-Lisp. Here.
Okay.
I don't want to chew D though.
Oh, apparently we have a nice syntax for it. Go up there.
There.
Oh, oh, like becomes, right?
No, but this is the question.
Okay. It's like, wait, why don't you go on the first answer first?
Because this
The
is
best
implementing. Because this is already this is the implementing. We don't want to implement. We want to already implemented. Okay, so it's saying the difference between like a hashtag and the quote. Let's try that.
Okay.
Here. So this. And just do, I don't know, something like this, and then this, and then this. Invalid index 4 for simple vectors 3 should be a non-negative. Oh, so it throws an error. It's not returning new.
Oh no. Oh no. Then we need like a catch or something.
Arrays in Common-Lisp.
Maybe you can also access in another way. Like,
no, but that's a vector. That's not an array. I think they are different. Arrays.
Wow, one is like dynamically sized.
Array creation. Oh, so you need to do it like this.
That's then we have the initial. Oh man, no, take a look. Make array. We are passing the dimensions. Then we pass the content.
No, but we kind of don't care.
How's
yeah, we
that?
kind of don't care. We don't care about the content, man. We just care about the dimensions.
No, but we need to pass it to make it.
Oh no, I did something wrong. I think I also did something wrong.
Like, if you don't pass the value, does it have a default value, like in use or something?
I think I removed code by accident.
Oh no.
I removed code by accident.
Can you just Control Z?
Undo. Okay. Control X, Control E. Okay, so it's still throwing this. I don't know why. Control X, Control E. Yeah. So if I put, for instance, instead of put 1, Control X, Control E. It's at the top. No, it's at the bottom left. I was looking at the right.
Oh, me also.
Okay, so now let's put 4 here. And now it throws an error.
Oh, okay.
Okay, maybe we need to initialize the values, which is sad.
But you were having 0, so you don't need it.
Yeah, I was having 0. So yeah, so in the make array, if you try to do consult out of bounds, it just throws an error.
How to handle exceptions or errors in Common-Lisp?
Oh no. Why?
Yep.
Why?
Yep. That's the reality.
You don't have any other way of doing your
Well,
trick?
if you have another way to access an array,
we could just do an if, man.
Hmm?
We could just do an if. We have the dimensions of the array.
oh yeah. You can check if the sum is like greater than the. Yeah. You can do that.
Okay, so this is gonna be
It's much worse, right? But yeah.
or right. It's gonna be we're gonna do and this or. Is that right? Nathan, are you there?
Wait a bit, man. Yeah, like on the board value. Oh yeah, you just like. Oh yeah. That's actually not as bad. Like, see the board value. That will be a OR between this check and the check if it's out of bounds.
So it's gonna be and this or something else.
Wait. Oh no, actually no. Well, it can be, but you have to do like 3 checks on the left because you need to check for out of bounds in X and in J. Yeah. So see, you have left and right, okay? The left, you are checking if the board value is 1. But for us, that could be either, that is, using a OR on board value is equal 1, or one of the indices is out of bounds.
How do you define that an index is out of bounds?
Well, checking by the dimensions that we have on the... so
we need the dimension.
Oh, fuck. Yeah, we need the dimensions of the board. Yeah.
No, but we can have that. That's fine.
Yeah,
we just do another destructuring. But that's the thing. I don't know how to do multiple destructions because we only needed one per function. Oh no, you just do like this. Oh man, that's gonna suck because because we need to nest it. Oh no, I'm so sad.
Not as bad. You don't need to move that much code. It's just indentation of all of it.
Which is the problem, right? I already lost the thing here. Oh, it's here.
Man, I bet you that in JavaScript we can do everything in one session or 2. Well, if you already know what we are doing, right? But yeah.
Which we don't, right? So.
Well, now we kind of already know like everything or almost everything.
Okay, bx and b board.
Oh my god.
So let's do board instead of b. Board.
Yeah, but that's not X and Y. It's not a position. It's like dimension.
It's rows and columns.
Yeah, if you want to call that.
You don't want to call it that?
No, it's because it's not actually rows and columns. It's the size of rows and columns, right?
Oh, you still understand that? Okay, maybe removing the plural.
No, it's because no. It's still like, what is a row? A row is a vector, right? Or an array. But that's not what we have.
Okay, so you want something like how many board rows?
Yeah, like the size, you know.
Okay.
Or the length.
Row size. No, row size is fine.
Okay.
Column size. Let's actually change this to size, and here as well. Okay. Now, can you try to explain to me, because I still didn't get the idea about the boundaries using this check. Can you explain to me the idea?
So you see that we are doing some arithmetics, right? To get the x and y that we are going to fetch the value from the board, right? On the line 180.
Yes.
See? So that arithmetic could result in an invalid value that is out of bounds. How do we check for that? Well, we know the dimensions of the board.
But how are you going to treat the case where you have zeros in a column or a row?
Huh?
Yeah.
No. See, that's the thing. The only thing that we are worried about is if both are 1, right? So on the right, it will still be the same. It will be if piece value it's 1, But on the left, where you have this V equal, that will be a OR between that
I
and
got
the
that
other
point.
checks.
I got that point, but what I'm trying to say is that a piece that is starting at a position, like a position out of bounds, if you consider that the dimensions of the thing.
Yeah, it's easy to see. Like, see the left. If the left it's true, let's say it's true because the case is that is out of bounds, right? But the other, the right is false because it's 0, then it's not a collision.
Wait, I'm digesting the thing.
Okay.
You're saying to me.
So our condition is the value on the board and the value on the piece. If both are ones, then it's a collision.
Okay.
You agree if that's not exactly the case, then we don't have a collision?
Oh, so if you are out of bounds, but you are a 0, that's fine?
Yeah.
I see. Clever. Clever move.
Literally a move.
Okay, so we're gonna do a NOR, and then here, and then this. This.
Or checking out of bounds for the x and the y of those arithmetic values.
Okay, let's not do that here. So let's do an let star.
Even because this, we need to do, we actually need to do the checks before accessing the value.
Yeah, no, we can pick this. Wait, what you said is important.
No, yeah, because see the a ref, that will throw an exception array. So before that, we have checks for check to. Oh no. Man. Ooh. We cannot do this let before checking. We cannot.
I don't understand why.
Because see.
Because you're gonna try to reach the part of the board that is out of bounds.
Yeah. Unless. Yeah. We need to do a check, I guess, before this let.
But man, then we have a problem, I guess.
Which one?
Because what we're gonna check and do what? If we are out of bounds, what you're gonna do?
Well, if we are out
because
of
we still need to check the piece, right?
Yeah.
Man, I don't like this.
Yeah, I don't know how to write it in Common-Lisp, but you got the logic, right?
No, I think I know how to write it in Common-Lisp as well. I think. That's just a guess, though. Because I think what we need to do is the following. You need to do an if, like here, and then if, then the condition. Let me just check how we do. Yeah, you do like that. So you're just gonna do here, and then here you're gonna check out of bounds. So I'm gonna put it here. So out of bounds. Later we can deal with it. If it is out of bounds, what should we do? Nothing, because we still have to check for this.
It is not nothing, right? Because on the if, well, on the then and on the else, we could have like conditions.
No. I already got it. Look at this. I think you're gonna like it. I don't know the shortcut for undoing this crap, so I'm doing it manually. Let's just remove this.
By the way, we have like 20 minutes or so.
No, just believe it, man. Believe it. We're gonna remove this star as well. We're gonna always start by picking the piece value. Okay, and this is wrong because I'm doing it the wrong position here. We're gonna always start by this, which means that we need to. Oh, I cannot control the parentheses here. Okay, wait. Let me just remove this, I guess. And we need to get rid of this board value out of here. So I think it's like this. No. I think this is correct. Yeah, this is now correct. Now we do an if. So here we're gonna do if. This will check for out of bounds.
Actually, on this let, you could do the arithmetic before, right?
Which arithmetic are you talking about?
Well, the plus stuff, and also assign these out of bounds variables.
Cornero.
Hello.
Okay, makes sense. Actually, what you said, Nathan. So
All
we're gonna
this time
do.
when you guys just did 2 lines, is that it?
Yes, that's about it.
Okay, so what are you doing?
Row checker, I guess.
We are doing the default case for
No,
when
not.
it's out of bounds.
Yeah. Wait. You want to do a slet for this, right?
Yeah, and
Okay.
also
What's
for
the name
the
of this
other.
crap? Board X, I guess. And this is gonna be I plus piece pos X. And I need to, like, I can't deny it. I'm already kind of getting used to the hell of parentheses. This.
They start to disappear.
That doesn't sound like a good thing.
They blend in.
After some suffering, you get used to it. It's exactly like that. And then this let that we are making will also have the out of bounds.
Is out of bounds, right?
Is out of bounds. Is out of bounds. Then what is this check? We need to do 2 checks, I think, here, right?
Like it's an
So
OR.
it's gonna end. It's an
No,
OR.
it's
Sorry,
an OR.
also it's an OR with two things. The first is greater if it board X
Greater or equal.
greater or equal than this, right? Board row size.
Yeah, you have to take a look on the order, right? Oh yeah, that's correct.
And then this is also the same thing. So it's board Y. So this means that this needs to be a let star. We are doing that with, oh Jesus. Okay, board column size. Okay, then we check is out of bounds.
No parentheses.
Where?
There, you're calling the thing.
Oh, it's because this is already it's not an expression. It's
Oh
already
wait,
a label.
actually I don't know how it works.
Wait, what?
If you have a label instead of an expression, do you need parentheses?
No.
Okay. Okay, and then if this is true, this means that we should return.
Not yet. We need to check the piece value, right? Because if the piece value is 1, it's still a collision.
Okay, so then the return of this is easy. Wait, I did something wrong. Are you sure you don't need parentheses in the label,
Yes.
Magit? Okay, so I'm definitely.
It's just checking for if the piece value is 1.
Wait,
yes.
What is... Oh, why did you do... Wait a second. What? Is out of bounds. What is
It's just a boolean. It's a boolean.
No, is out of bounds. Like, yes, there. Exactly there. So why does he have parentheses there?
Because this is inside a let star.
No.
No.
Remove this parentheses.
I can't.
Yes.
I know that I can't.
No, remove the one closing.
I can't remove, man.
What? Why?
Yeah. Because of the protocol.
Oh, okay. It auto balances. That's why you're showing. Okay.
Yeah, you didn't got that before.
Okay. No, but here's the thing. I know the package do MetaX. It's probably using.
Forget about packages.
No, come on.
No,
That's too much.
It's just a mode, man.
Bounds. And then we just need to do some sort of like this.
You need to port the thing inside, right? That's what you want. Yes.
No, but I'm moving these now. I don't want to move these.
Yeah, I don't know which package it is using. That's the problem. Like, I just want to deactivate.
Redo. What's the shortcut? I don't know.
Ctrl X U.
Ctrl X U, you think?
Ctrl G first. Ctrl X U.
Ctrl X U. Ctrl X U. Ctrl X U. U, right? You're saying Portuguese crap.
Yeah.
Please type the space bar.
Ctrl
No, I don't
G.
want.
You misplaced.
Ctrl X U. Ctrl S U.
Dude, just cut the expression. do like this. You want this to be that or, right?
I think this is not saving the history, so it doesn't know. It only goes back and forth, back and
I
forth.
don't know what protocol's doing, but just put the thing, or just edit on Visual Studio if you feel more comfortable.
Okay, we surrendered, guys. Basically, we just surrendered because it's too hard for me.
I think it's using some strict mode, like that it auto balances parentheses, but that just works if you know how to use the three things.
No, but I made all of this using that, man.
Yeah, and there you screwed up.
Okay. I think it's a blue here.
Yes. Yeah. Now another one.
Another one for who? For the let. No, we don't want no when the let.
Yes. Now.
Don't close the let.
Yes. No.
Here?
No, that's right. No, man. Go back there.
Here?
Yes. You're not
we don't want to close the
let. You're closing the bindings.
Oh, I'm closing the bindings. That makes sense now. Okay, so now the question becomes, is this correct?
Yes.
Okay, so then if I do this and I do tab.
No, that's now wrong. That's wrong.
Now wrong. What's wrong about it?
You need to go inside the if. Enter. You didn't. Yes, no, that's right.
By the way,
now here. It's the true expression and then the
expression is this one.
By the way, we have to change this if. Is better if that is a end, checking for that, and already for the piece value. And why is that? Because if you put that inside the if, you cannot just return that value, right? And if it's true, you want to return. If it's not, you don't want to return.
No, but we can get around that problem, Nathan. Just creating a new guy here. Like answer and then new. And then here we do a set f with this value.
Okay.
So this will be an expression. So this is parentheses again. Set f. I already forgot. So it's where we want it, and this is in the case of answer. And you want to center the answer of this expression. Like this.
Yes.
Okay. But if this is not the case, what we do, Nathan? Do this, right?
Remove one space backspace.
Backspace.
Yeah, so that's how we did that.
If it's not out of
bounds,
then we should check for the 1, right? Oh, we need to do the access and check if the board value is 1.
Oh, we need to do a not let here. Because if we're not out of bounds, this means that we can finally get the board value.
Well, we could have done the catch, right, and just put the default value.
It's because, Mageta, we discovered that if you go out of bounds in the array, instead of returning new, it returns an exception.
Oh.
So wouldn't it be easier to just capture the exception, and if it's okay,
no, I refuse it. I refuse it. I am not allowing
it.
Okay. Then we get the border value, and then we just do. Actually, it would be nice to have this in the previous let. So it would be something like this, and it would be is piece. I don't know, 1. And then we put the parentheses, put this condition here there, like this. Then here we put is piece 1, and in here we're gonna do this end here, but instead of this parentheses.
Yeah, but the is piece 1 you have show. Wait, what? Oh, okay. You did a value, not a function. Okay.
Yes. Now I need to. Yeah, now it's a parenthesis hell already again for me.
Okay, so you need to put this end inside the let.
Yes.
So just copy it. Cut actually.
Actually, first a parenthesis because I'm already gonna put the set f. Set f answer, and then inside this parenthesis is this end.
Mm-hmm.
So here.
Yeah. Okay, I think just.
Sorry?
Just remove the new parentheses down there.
The new parentheses.
There's
this
one opening and closing, like the first.
Oh,
one.
here.
Yes.
Oh, and this is done then.
No, it's unbalanced. It's like one
yeah,
parenthesis.
It's unbalanced. It's missing one.
Just add one. Yeah.
Oops.
Oh, it looks like I don't know, man.
Looks
like you know those ice creams of like that has multiple layers.
Hey, that is something wrong there. With
yeah, we don't need the never anymore.
Oh, what?
Yeah, we don't need the never anymore because now we are just doing set F.
Oh, okay.
The never was to short circuit.
Yeah, but see the OR there.
The OR?
On the last line.
Where? Here. What's the problem with it?
Last line.
Last line here.
Yeah.
We are doing or this. Oops.
Or the board value is 1.
And then end with only one value.
Oh, this is legacy code. This shouldn't be it.
Legacy.
A legacy code
Oh,
from 2
when
minutes
someone
ago.
asks you, oh, how old is a code should be to be legacy? Oh, 2 minutes.
Yeah.
Yeah.
2 minutes and 30 parentheses.
Well, it depends on how ugly it is, right? Depending on
Is
how
this
ugly...
right then? Is this right?
Why the... Wait... Yes.
But look at this parenthesis not matching.
Wait, it is matching. Wait, what the heck? No, oh, right. Go back there.
Go back here.
Go back to the third yellow.
Third yellow here.
Yes.
Here,
No,
this
one-
yellow.
Yes. So this yellow is the 4. So it's lacking 2 more. No, 3 more.
Just add parentheses until it stops. It's
Are you
stop
sure?
complaining.
No, it's actually balanced. That's right, man.
Yeah, but these ones are not.
I think you misplaced there then.
Wait. The last one of the line should be closing the defunct, right?
Yeah,
that's
it is.
right.
Look.
Yeah, it is
Oh.
correct.
Okay, now let's do Control A, Control C, and now go back to portable and see what.
Oh no. That's so bad.
And here it is, our creation, and it is balanced.
It is a monster.
Probably it's not working, but let's see.
It's probably not.
It's probably not working. We all agree that. So, guys, we need test cases, like boards and pieces to test.
That's sad because doing boards, we need to do them manually, man.
Yeah.
Oh no.
Oh no. Okay, so can we
Okay,
just
now use
read
the
this
REPL.
and see if this makes sense?
No. That's.
Let's use the REPL first, man.
The REPL. What do you
Try
mean?
to just evaluate this function to see if it doesn't complain about
Go to the other thing up there.
File.
Oh man.
Wait. What you said, Maggot?
Go to the other thing. You see the thing failing on the right?
Failing on the right. Yes.
Click there.
Abort.
No, anyway, yeah, it could be. Okay. Now Control X B. Go to search for REPL. Yes. Now go back to the code. Go to the end of the
Control
file, and then press Control C, Control C.
Control C. Control C. Control E. Right.
No, Control C, Control C. So there's a bunch of warnings and errors.
No, one arrow. That's nice. One arrow only.
Wait.
This
Let's
boss
read.
is defined but never use it. Oh.
Wait, a binding spec. A ref, blah, blah, is malformed. So, let me see. Oh, lacking 1 parenthesis in the left, before the board value.
What the fuck, Magetta?
The guy
no,
knows.
not there. No.
Oh my
No.
god.
The board value should be inside the parenthesis. All of this thing. It's
Oh,
it's a
okay,
list
okay,
of
I see.
bindings.
Yeah, it was not the name, right? Oh no,
Yeah.
the let.
I know. I'm confused.
Another one.
Do you know it's not how it works? You
What?
want to do,
That's why it's
do
unbalanced.
this?
Like, yes.
This?
Yes.
Okay.
Now it's unbalanced. Go to the end.
No,
it's
it's-
balanced. I think your thing is already balancing stuff around. Yeah. Okay. Now eval
Okay, but-
again. Control C,
No,
Control
no,
C.
but I have a question. Why is this? I think this is weird. Why we need 2 parentheses here?
This is a macro. Like, let me explain something. Like
Like the
let me
inner
actually show.
parenthesis is
Hang
one
on.
binding.
Yeah, I have one code that will.
Oh,
enlighten-
it's because it's a sequence of bindings. No, never mind. Never mind.
But here's the thing: why doesn't it require a tick, right, to identify the list? It's the same thing as the set queue. Do you remember Commander talking about that?
Set Q.
Like set queue
Yeah.
requires it is basically a set that doesn't require you to type the quote, right? because it's a macro that already abstracts the quote for you. This thing is the same thing because it's already abstracting the. I think so, right? I'm not like sure, but I think this thing is already doing the thing because remember the identity monad that I was talking about.
Yes.
If you do the identity monad there, then it's the same thing as basically doing, evaluating a sequence of bindings. So we're gonna end up with like 2 expressions, so you can bind the expressions each in a list. In this case, you don't need the list because it's a macro that already like gets.
Okay, no, I got the idea. It's just because you have more than one. Okay, undefined variable piece pos x. Did I write piece? Yeah, it's here.
Pièce pos is x. Yes, that's right. X. Lambda calculus.
Oh
okay,
man,
why I can see here? Okay, so it's never used. It's saying that it's never used.
Ctrl C, Ctrl C.
Oh
okay,
my
so
God.
just ignore it.
Undefined variable piece pos x. Are you sure we can ignore it?
Yeah, no, I'm not. But let's try. Let's try to ignore it.
Piece matrix. Yeah, nothing in this let is being correctly identified.
Let me see. Oh, the balancing. Oh man, go to the end of his let. Yes. So you're closing there. Remove this.
No. It's not gonna happen in here. It's not gonna happen in here.
No, but even I could see that.
Okay, so here and then another one here, I guess.
Yes. Now it's right. And then you need to indent the loop.
Indent the loop.
Yeah, do that on Emacs. It's better. Just save.
Yeah, let's first save, and then copy this here.
And now do the following. Yeah, press Ctrl Alt H. Tab. Okay, it's already indented actually. Okay. So now Ctrl C, Ctrl C.
This is the exercise of our lives. Ctrl C, Ctrl Z. Okay. Now.
Warnings.
So
yeah, but now the let. I think the let is the same then. No.
Yeah.
No, it's not.
No, it's not.
So what's the problem? Can I see the problem?
This variable is out of bounds. Is defined.
Oh, it's because I don't know how to write. Is this? Okay.
Okay, you're illiterate.
Oh, it works.
No location.
It compiles actually.
Wait, redefining has collision in the fun.
Has collision.
Okay, like it's just because you compiled. Okay.
Yeah, but now it works then.
Yeah.
I don't know if it does what we need to do, but it works.
Yes, but
it's compiling whatever you guys say. Okay, now.
By the way, it's already 9.
Yeah, but we started like 12 to 15 minutes late.
So I think that basically we should test with cases and that's it.
But there's a problem though. There's a problem.
Why?
We need to do the board manually.
Yeah, that's not a big problem, man.
That is a ginormous problem. It is a ginormous problem.
You have the one there.
Just do hard. Dude, monkey code. Just to like think you're a monkey programmer. That's it.
And then hit the keyboard.
Yeah, hit the keyboard like you're a monkey.
How exactly? I think it's a def parameter in this case. Okay, so let's do it. Def parameter is going to be a test board. And then here, I think did I copy the parentheses? Yes. So Control undo. Remove this. And then this. Okay. Then tab.
This is already.
We need. Let's not do a board that is ginormous, right? Let's do something that is above a piece.
Oh wait,
so
like that's the test piece, isn't it?
No, this is the test board.
Oh.
6. Let's do it with 6. I think it's gonna work fine. And then do I have shortcuts like this? Not quite.
Wow.
Nice.
I'll be right back.
And what the fuck? Oh, it's because it's under. A close portable. No. Port.
You're pretty stupid.
We lost. We lost that. Oh no. I'm glad we have VS Code then. I'm glad.
Why did you download? You have Emacs already, man.
No, I have a prototype. Oh, it's in here. No, never mind. Oh, yes. Never mind. This is in here. Okay. Okay, so 1, 2, 3, 4, 5, 6. How many we have here? 6? Yes. Okay. This is a 6x6 board. Now we're gonna do we have a test piece. We don't need this by now, for now. And here it is. And then we're gonna do Ctrl+C, Ctrl+C in this thing. Okay. Right. That seems to be right. Now what we need to do, Magita?
Did you asking me? Or?
Yeah, I'm asking.
Well, you need to run the function. What are the things the function requires?
We actually
a
need
piece
to
and a
change
board,
that.
right?
Yeah, but let's try to do, because I think we're already trying to counter the out of bounds instead of doing all this crap.
I'm back.
So now we need to define the initial position of the piece. We have an L, which Nathan, you're here.
Yeah.
What's the best position to us to try to
Doesn't
check
matter.
for collisions? I
Like,
think it matters,
wait a
yes.
We
second,
start
that's
with
an
0,
object.
0, man, and we should not get collision.
No, a spawn piece always starts in a 0, 4.
Hmm?
Yeah.
Oh, okay, but then it starts
which
with
is
that,
the
and we
middle.
should not have collisions.
Yeah, but wait a second. You're doing a setf on the position. I don't know if that will take on the.
We have to
And the
spawn the thing, right?
No, but the spawn
but
is here.
here's the thing. No, but
Huh?
you need to assign. You're spawning the piece, right? But that's like not.
Yeah,
Like you're doing setf not on the object, because you gotta think that the piece is actually an object, right?
No, but this worked last time around. Do you remember? We did
No.
this last week. We did
Yeah,
exactly
I
this.
just don't know if this will work, but try. Like
Okay. Ctrl+C, Ctrl+C, Ctrl+C. Okay. Now I need to go to back to the repo.
Oh, probably will, because it will expand the setf to get the function.
Okay. How we're gonna do this? We're gonna do this has collision. Then everything is basically labeled. So it's test board and test piece. Is that right, Magit?
Yeah.
Nice.
Test board is unbound.
But I did Ctrl+C, Ctrl+C here. So I'm not understanding.
Unbound variable. Oh, package. Go to
Oh.
the repo.
What? It's like something like this?
No, just press comma.
Comma.
Mageta, man,
In dash package.
like, being honest, man, like, it
Enter.
has a really tough user
Be
experience,
very
right?
careful on what you're gonna say. Then.
No. Let's just finish this crap, dudes.
Enter.
Later we complain about this matter.
Enter. And then type the Letris, yes. I think he needs the. Since we added a number, we're dumb. Add like a pipe. Letris.
A pipe like this?
Yes. And a pipe in the end. Yeah. Now it should be there.
What's the command to get back the line?
Meta P. And by the way, the experience is amazing. You just gotta know. It is, man. You just gotta know how to use it properly.
No, what I mean is like the
This is not
onboarding,
like
right?
the way-
Okay,
Oh no, the
1, 3.
projection of the
Complaining.
piece, not the piece. You're passing the piece, not the projection of the piece.
What do you mean?
Like the piece
No,
there, we
we-
are assuming it's an array. We're not passing an array. We're passing the piece itself.
No,
Yeah.
we
The
want the
object.
piece itself.
We own the piece itself.
But we are getting array dimensions of an object. It's not an
Oh,
object.
no,
Oh,
no,
yeah,
no,
that's
no.
true.
So this is a parenthesis, this
The
representation.
representation.
And
But,
then Ctrl+C, Ctrl+C.
But what I mean is the onboard for the initial people, right? The beginners one.
Oh,
yes.
beginner.
New.
Yeah.
I think that's right,
That's
though.
false, right?
Yeah.
That's so weird. Now put something like absurd, right?
Okay, so
It's true.
let's put something
Then we just said
completely
I'm
out of
not.
bounds.
That's it.
Let's put something completely out of bounds.
Okay.
Okay?
Ctrl C,
Da-da-da.
Ctrl C.
No.
We have an empty space there for some reason.
Good question. I don't know what that means.
No, it's just a visual bug.
What the?
Not sure.
Okay, so the out of bounds is
Oh, okay. Maybe the set is not working.
I think it is, man, because you can just do pause,
So
test,
can you-
piece. See? It is working.
Yeah.
Can you
it's because
evaluate the object?
We are not returning the answer. We are dumb. Wait.
Oh no! Yeah.
Where do I describe?
Now count parentheses, my friend.
No. Wait. Go. No. I would say you're warm. Yes, you're pretty warm. No, it's colder. No, it's
No, but
colder.
you are declaring the answer in the
It's getting
left.
warmer. It's getting warmer. Very hot. Very hot.
Like left.
No, it's getting colder. Oh man, you gotta do a binary search to find yourself in the princess. I think it's wrong.
You think it's wrong though?
Because you
Yes.
have to be inside the left.
It should be inside the other destruct bind, the second.
Oh, here.
Yes.
Not
Okay,
only
remove
that.
the answer.
So it's in here.
Remove the answer, yes. But remove the previous one.
No, Nathan has a point though. Because this answer is being declared inside the let.
No, man. It's inner. It's inside the thing. No, it's not like going outside the parentheses. It's actually inner. No, remove it. Remove this thing. Remove. You're going outside. Go inside.
Just say left and right, Magita.
Yeah, left. Enter. Answer. There.
That's monkey program.
You're laughing out of despair, man.
Yay! Answer
Which
is
is
unbound.
Because it's outside the let, right?
No,
yes,
it's in the let.
outside the let. No, it is outside the let.
No, so it's one more.
Yes, one more inside. I didn't see it.
Oh my god!
I was looking at this.
Fucking annoying parentheses.
This?
Yes. No, it's
No,
one.
it's four. Four parentheses.
Oh my god.
Yeah, you're highlighting the correct one. That's there.
Here. Oh man, this is so funny though.
Press Q when that happens, like when that shows up.
It's still wrong though.
Okay.
So it's pause, test, piece. Yeah. So this should definitely be out of bounds. What is board X?
Isn't
Board
that-
X.
Oh, has collision is actually true. Okay.
Yeah. So for instance, this I at some point needs to be. Wait. No, wait. This doesn't make sense though, I guess. Because piece pos X is the X of the initial position.
Mm-hmm.
And I is always all in the domain of the piece. Yeah, this doesn't make any sense.
Oh, I see. Yeah.
No, wait. Oh no, it makes sense because this we are trying to get the border relative coordinates using this.
Yeah.
No, it makes sense. Yeah, no, this makes sense. Okay.
Okay, the shadow, right?
Yeah. So this is when you are checking if board X it's greater than the size of the rows.
You
Yes,
can
okay.
think of I and J as padding.
That's hard to me. I'm dumb. Anyway, then you're trying also to see if this is true. When you're checking if the Y is greater than. Yeah, but this should be the case because this is 1554. So piece pos X should be 50, and this should be 54.
Well, what about print inside the if? We
Here
can
you
print.
mean.
Yeah, we can print either before to check the values of the LEDs, or just check inside the then branches.
Wait, I wasn't looking.
How do I do a print?
Oh, print or format. Use format. You have print C and print.
You just stole the parentheses.
True. Yeah, you just stole the parentheses. That's true. Wait, you want to print on before the setf, right?
Yes.
So do the following program.
Oh my god.
Remove the format.
Oh, that's why you're guys talking about the parentheses.
Program. Yeah.
Never mind.
I guess it's a thing, right? Like
do program. Add a new parenthesis outside. If I don't know if Emacs will complain. Yeah, because of that. Okay.
What
now program, and then you do a bunch of expressions. So before the program, like before this parenthesis, enter.
Before enter.
Yes, and then enter again. Yes. Now make your format T. And then your like thing to print.
Okay, so here.
Okay.
We are checking if we are actually getting to this if, right?
Yeah.
And we're
here.
yeah, I think we are.
I think we are, but which piece we're trying? Oh, this is an L. No, but this is 50-54. Yeah, that doesn't make sense whatsoever.
Oh, wait, we need the else. Print also on the else.
Yeah, print on the else.
Because if it doesn't print anything on the else, then it's correct.
Oh man, I don't want to print the else.
Man,
Look at this parenthesis.
Copy and paste.
No, it's not, man.
Yeah, you just copy and paste the prog and
instead of copy.
I hate this.
Do the following, man. Do like this, Lemos. Wait, don't despair. Go before the let. Go before the let.
Okay.
Yes. Now press Meta X. Type S. XP, like S expression. Yes. And then Q. Yes, that. Enter. Okay. Now do the new parentheses. Add your thing, make the program. Yes. Enter. Add the format. Yes. Enter. Now Control Y.
Y or I?
Control Y to paste. Yank.
Ah.
Yank.
Thank you, Magetta.
Those names. Man.
You're scared, man. No,
I'm not scared. I'm just.
We can feel it.
It's not about being afraid or scared. It's only about it's necessarily exhaustive.
Yeah, that's true.
Okay, so let's do. No here too. Which makes sense because we are always out of bounds. Because look at this. But then something is.
The out of bounds is an OR that we check if it's greater. Oh man, wait. Board X. What is board X? Board X is the sum of the initial position. No, the position we are currently in, right? Plus the initial position of the piece.
Oh, I know what's happening.
Mm-hmm.
I know what's happening. This piece value here it will be at the end of the loop. It will be 0. It will be new because this is an L piece. So the criteria that we are using is that if you are out of bounds, just check.
Oh, okay. We are always setting.
Yeah.
Oh. Oh man, good catch, man. Good catch.
Okay, so what we need to do is to basically.
I see, makes sense.
Just remove this set.
Wait,
but
we do a OR. We set the expression. Wait, OR or N? OR. Yeah. You set OR, true, and the expression, right? No, wait.
Actually,
no, that's wrong.
There's a better way. There's a better way. You just put a not in this, and then you do and all of this, and you are not out of bounds.
Wait, can you repeat?
Okay.
Yes.
Yeah, I get it. Mm-hmm.
This is checking if you are out of bounds, right?
Yeah.
If you put a not in this will become is not out of bounds.
Okay.
And then we're gonna do and all of this and another and with this.
I'm too distracted to follow this, but go on.
Okay. So I need to do some trick with the parentheses again.
Wait, what do you want to do?
But hey, by the way that I was thinking is you set F, answer, or the expression. That solves already.
The answer or the expression?
Yeah.
That doesn't make sense to me.
It makes, because if answer is already 1 and the expression is 0, then the answer will be 1.
Yeah, but what expression are you talking about?
No. See where you are doing set F.
Here.
You are setting answer to an expression, right?
Yes.
So you would do set F answer to or answer or expression. That would solve already.
The another expression would be something about the bounds.
No. See, you are doing set F answer, right? And then you are setting all of this to a value. What is the value? Is the value that this expression evaluates to.
Yeah, but that's not gonna work with the or, because this can be true.
No, it works. Like, see all this value, right? This whole will be or answer or this.
But that's wrong.
It is right.
No, it is not right, because this can be true.
Yeah, if that's true. No, or.
Yeah, if you're using an or instead of an and.
No. Right? I know. Again, go to the other set F. It's easier.
This.
Yeah. What I'm suggesting is set F, answer, and then or. Or answer, or is piece 1. Because if it's 1 on answer already, he will maintain. If not...
That's not right. It's gonna be the same problem.
No,
because this
it's not...
Yeah, it is!
It's
because
not,
this can
because
be
if
true.
you have like 1, 0...
Wait, folks. Let's go back. Like, everybody's confused.
No, but do you agree with me? Just answer yes or no, Nathan. Do you agree that even if we are out of bounds, this can be true?
Wait.
Do you agree?
I agree.
Yeah. Wait, but it's not a question regarding our checklist. It's only about the set. Problem is the set.
Baby steps. Do you agree with this?
Okay,
this can be
go
true?
again.
Do you agree that this can be true regardless of being out of bounds or not?
I think so.
Yes, okay. Do you agree that if you do a set F using an OR operator in here,
okay,
like an expression with an OR, and this is involved, do you agree that the final result that we are going to set is true?
It depends. Like, if this is false and answer was false before, then the result is false.
And okay, but that's not the case that I'm talking about.
Okay,
I'm talking about the case that this is true.
Okay.
But we are out of bounds. Okay, so we're gonna enter here.
Okay.
You're proposing to do set F using an OR with the previous answer in this.
Yeah, but that's the thing. If the previous answer was 1, then it's okay. It will still be 1. And if it's 0,
but that's not the problem. That's the opposite case. That's the problem. If the answer was previously new, and should be still new because we are out of bounds.
Okay.
If that's the case, this will set to true because you're doing an OR.
Wait, the answer previously was false, right?
Yeah, it was new.
And what is the result of is piece 1?
1, true.
True. And then the result should be true.
Should not, because you're out of bounds. This is a piece completely out of bounds.
No, but that's what you are doing right now. You are setting F to this, and if this is true, the answer is true. That's what you are doing.
But this shouldn't be true. This shouldn't be true.
So you are saying this piece of code is wrong?
Yes.
Oh, okay. But
so this should be and answer. I guess.
Wait.
Let's just try.
Wait, man. I think that...
Yay! Unbound. Oh, it's because I removed the name.
Wait, can you explain that to me? Let me see. Is piece 1? We check if it's out of bounds. If it's out of bounds, it means that the value on the board is being considered as 1, right? Implicitly.
Yes.
And then we check
it,
and then we check if also the piece is 1, right?
Yes.
Man, so that's wrong, because if the answer was new before, he will always be new, man.
No, I agree with that. I just noticed that because this starts
just
as new.
Change for OR and do the same in the beneath that.
No, I I think that the OR is wrong though. So I'm gonna try this approach first, just to check, and then I will try yours. I really think that the OR is wrong. Okay, this also didn't work.
No, just keep to me like in abstract level. You have the previous answer and the new one, right?
Abstract level. Let's talk about abstract level.
Okay.
So, do you agree that if a piece is out of bounds, completely out of bounds?
No, wait. No, I mean more abstract than that. We are not talking about this programming specific. We have an answer that is being stored, right? And we are having new results to set on that, right? But our condition is, if at any time the accumulator is true, he should never go back to false.
That's not right. That's not right. If the accumulator, if the accumulator gets true because of this, but we are completely out of bounds, this should not remain.
The accumulator that I mean is answer.
Okay, that's exactly what I'm saying.
But the accumulator has collision. If it had a collision somewhere, it will always have a collision on the whole board. It's not if it doesn't have collision, if it has collision.
Oh, I think that's the catch. I think I was thinking about the older.
Right?
Yes,
okay.
Yes. Final attempt.
Yeah, but we also need on the.
Yeah, it worked.
But we also need on the other, right?
Okay, so let's explain to Mageta.
I wasn't even looking.
Okay.
Wait, but please, first write the code. All the set need that.
The other set need this, you say?
Yeah, always when you set answer, you have to account for
so a new parenthesis. This needs to be
or answer.
No, this is okay. Or answer.
Wait, what?
No, put the answer first. Like it's easier, right?
I don't know what's easier actually, but anyway. Okay, so Mageta, look at this, man. What we are doing here. We are doing basically, if at some point in time, because you agree that answer, when it's true, we have a collision.
Mm-hmm.
Okay, we start assuming that we don't have a collision. If at some point during this loop, if we find a collision, these ORs that we just added are maintaining the previous state. Do you agree?
Mm-hmm.
Okay. So at some point during this loop.
Wait a second. Like if we find since we start with new, if you have an OR, it's gonna be the new state of the end, right? Inside the thing. Like
it's gonna be the following. If answer is new, the OR will always evaluate this.
Yes.
And if the answer is already true, it doesn't really matter what comes after.
Okay. Mm-hmm.
That's the thing. The thing that I'm not getting, Nathan, is when during this loop, answer will be set to true.
Well, it's exactly how you said it, man. You said the answer already. You said when answer is new, the result is just the second of the OR.
Yeah.
That's when he will be set to 1.
No, but I think this code will break.
True.
I think this code will break. You know why?
Why?
Because not in this particular case, because our pieces always have at least one number 1, which means that this is gonna be true at some point.
No, if it's always 0, then you are right. It doesn't have collisions.
Right? I don't know if I like that. What do you think, Mageta? Are you okay of having a piece in location 50-50, but it's all zeros? It is all zeros. This function
because I think it shouldn't
no
even
collisions.
be there.
No, but suppose that is a piece with all zeros. It makes sense because it would not show for the user anyway.
Yeah.
No. I'm talking about the logic, like the modeling of this function. I think that if we have a piece, regardless of its contents, if we have a piece that is so far,
no, but inherently the way of checking for collisions, it is checking off ones. Zeros doesn't collide. 0 doesn't collide.
Yeah, like I think I see the problem, but I don't think it is a problem if we.
That's not a problem, Lemus. Not at all.
If we limit the domain in the first place.
Yeah, I think you're right, Mageta. I think I need to accept that, okay, but in terms of the meanings of collisions and the meanings of the game, because a piece always will have a 1, This is kind of fine.
Even
Although
this
I'm
considering,
really bored by this.
like even
Yeah,
this
like, we
considering the
can just-
game.
We can just restrain, man. Like, we can restrain the position of the piece can never be that in the first place. So it doesn't make sense to check
No,
for that.
it will never be because we have the initial and the rules. The rules will never result
Okay,
on that.
Magenta, help me to remove the print so and we can finish
Yeah.
this.
So go to the beginning of the setf.
Mm-hmm.
Okay, you just cut. Now remove this. Yeah, man, that's it. It's easy.
Easy, he say.
By the way, we still need to test, right? The thing.
Yeah, remove the format first. Will be a lot easier.
Oh man, like I really.
Okay.
That's just really cool, man. The has collision.
Is this correct?
Yes. Paste. Now
And then-
again, do the following: delete two backspaces before the thing, and delete this.
2 backspaces in here, right?
Yes. So it,
And
like
then
you
I can
see,
just
it is
do an enter here and then remove all of this.
Yes.
Okay. And then this. Oops. This. Okay. All of this. And it's fine. Nice.
Oh my god.
Okay. And moment of truth. True.
Oh, it's just redefining.
Yeah. Okay. So.
Normie piece that shouldn't be colliding. And then it's-
Normie piece.
Okay. Let's put a piece in a reasonable position, like 0.4, 0.5. I don't know, whatever. Here. And then Alt P here. Oh, this is a, oh no.
Hmm?
It's wrong. It's wrong.
Oh wait, wait is wrong.
0.5
This-
is what? Wait. No, 0.5
Yes.
is out, I think. One,
No.
two. It's fifth column. And then it's gonna draw an L, so that's out.
Oh, it's in here.
Yeah. So
Oh,
now
okay.
is
So
out.
it's 0.4. Okay, good catch, Magita.
I don't know if I'm right.
Ah! Because this is 0, 1, 2, 3,
Print the
4.
representation. I think it's easier. Print the representation. Just confirm.
Representation of
Test
the
piece.
test piece.
Oh.
That doesn't happen.
Yeah, this is correct. You see, Magita?
Wait, I can't see.
Look at this. You're gonna be
right?
row 0, and then 0, 1, 2, 3, 4.
No.
Then we have a 1 here, a 1 here, a 1 here, and another 1 here.
But
No collision.
oh, this is an L. Okay, I was thinking of a straight piece.
No, man.
Yeah, that's
We are all tired.
No,
That's the
right.
thing.
I was thinking of like an L to the right, and then it would be like on the third column, so that would be off. Anyway, that's fine.
Okay, so copy all of this. Copy back here. Save it. I will push this at some point. And this function is actually pretty nice.
Yeah.
And all of the work that we did.
Oh my.
the
Oh my fucking god.
Yeah, man. I think we should feel proud of this.
Well, deleting code is always nice, man.
I feel a little bit bad, being honest, but anyway. I still hate it, but now I can play around with the parentheses.
You can have. I think I will make that package to make them transparent.
You can end up working with closure. So you need to get used, right?
Okay, so Nathan, we can finish this thing here.
Okay, so let me finish the stream. So bye bye, folks.
Bye bye, archive.